Good evening. Welcome back to the sessions on computer organization and architecture. In my previous video, I have discussed about the significance of von Neumann architecture and how is it different than the Harvard architecture. Now, proceeding further, today I will be discussing about the Flynn's classification. So, Flynn is a great scientist who has provided a way to organize multiple processor systems. So, the most common approach to categorize the systems with parallel processing capabilities where multiple jobs can be executed at the same time is given by Flynn. The categories of computer systems as introduced by Flynn are SISG, that represents single instruction, single data stream. The second one is SIMD, that represents single instruction, multiple data stream. The third one is multiple instruction, single data stream, that is MIST. And the fourth one is MIMD, which represents multiple instructions, multiple data stream. So let us look into the details of each of these classification techniques. In single instruction, single data stream, there is one single instruction that runs on one single processor on to the data that is stored on a single memory. So we have a single instruction being executed in a processing unit, fetching a single piece of data from the memory. So generally, the uniprocessor systems fall under this category. All the instructions are executed sequentially one after the other. Hence, this architecture is also known as sequential computers. Most of the conventional computers or the traditional computers which adopt von Neumann technology fall under this category. The instructions and data here, both of them are stored in the primary memory. And the speed of processing in this single instruction, single data stream is defined in terms of the clock. Coming to the second one, we have single instruction and multiple data stream. In this approach, there is one single instruction which can be executed across multiple processing units, fetching multiple pieces of data across the memory units. So here, each processing unit is having an associated data memory for execution of instruction. So this kind of architecture is preferably used to perform scientific computations. So usually arrays and vector processing are the kind of applications that are built using SIMD processing. Because when we try to create an array, multiple pieces of information will be fetched at the same time and allocated to different array elements. Coming to the next one, we have multi-instruction and single data stream. So here, there are multiple processing units which are executing multiple instructions, but they all rely on the single memory unit to fetch the data. So practically speaking, there are no current systems which are built using this approach because this architecture is not implemented commercially. But where the speed and time constraints are immaterial, then this approach can be used. The last approach is MIMD, multiple instruction and multiple data stream. Here we have multiple instructions which are all executing across multiple processing units, and these instructions are fetching multiple data items from a single common memory. So there is a concept of shared memory in the MIMD mechanism. So this shared memory is known as symmetric multiprocessing system. So different processors, they basically take the instructions and data from the common shared memory. So program will be executed along with the shared memory through the help of multiple buses. The second category under MIMD system is NUMA. NUMA stands for Non-Uniform Memory Access. This NUMA is a costlier approach because every processor maintains its own local memory. However, the execution of instruction is carried out in an effective and efficient manner when compared to SMP processors because every instruction fetches its own pieces of data. Likewise, multiple instructions can fetch multiple pieces of data and execution can be carried out at the same time. So symmetric multiprocessors are basically represented by using certain characteristics, like they are represented with the help of memory access time. So this memory access time is the time taken by a processor to access the memory. So in SMP architecture, this memory access time will be the same. Also, all the processors, they share the input output devices through the same channel. They can also perform similar kind of functionality. Hence, it is named as a symmetric multiprocessor system. So this is how we have discussed about the Flynn's classification. To summarize, SISG category is a uniprocessor kind of representation. SIMD is used by arrays and vectors. MISG does not have any commercial implementation, and MIMD is further classified into SMP and NUMA, where SMP and NUMA comes under the shared memory, also known as tightly coupled processors, and for under the loosely coupled or distributed memory we have clusters. Thank you.